So George is supposed to be a Butler robot in the sense that he would follow you around and listen to what you command him to do.
We begin by building a map of the surrounding area by running the gmapping launch file in the Turtlebot navigation package, along with the view navigation launch file in the Turtlebot RViz launchers package. With these launch files up and running, we move George around with the teleop keyboard until he has a decent map. We save this map using the map saver node, and it is given to George as input when we run our own launch file.
So our code is divided in two parts. The first part is the part where we didn't implement, where we used ROS code. The first thing that's important is the localization, which puts the robot in the right position in the map. The second one is the Google speech, which is responsible for the processing the speech. The last one of the things that we didn't do is the soundplay node, which gives voice to the robot, allows it to speak.
George is quite simply a Butler robot. He responds to voice commands that are within his range of knowledge and acts accordingly to them. George uses a dictionary to store specified locations so he can revisit them if need be. This comes in handy when we tell George to store location and give it a name. He then can come back to that point by the go-to command. George must have a predefined map in order for him to be able to traverse the area.
Store location, water fountain.
Store water fountain as a location.
Store location, Taco Bell.
Store Taco Bell as a location.
Go home. The localize method actually just sends the robot a move command where the destination coordinates are the robot's current coordinates plus 1/10 of a meter in the positive x direction. This works to localize the robot because when we first launch our program, he's not gathering any sensor information. Go to the bathroom.
Going to bathroom.
And he assumes that he is at the x and y coordinates 0, 0, no matter where he actually lies within the map. Every time he's issued a command to move, he begins by determining where he is given sensor readings from the Connect, the map that was given to him as input, as well as odometer readings that determine how far he has moved in each direction. Once he is well localized, he can begin storing locations and navigating to them. Go to the bathroom.
I do not know where bathroom is.
Go to the water fountain.
Going to water fountain.
The entire time George is running, he is subscribing to two topics. The speech topic, which publishes the commands that were heard through the computer's microphone, and the AMCL map topic, which publishes the robot's current location in the map coordinate frame. Whenever the robot moves, the AMCL map subscriber updates two global variables that determine the robot's x and y coordinates.
Go to Taco Bell. Going to Taco Bell.
Our speech subscriber splits the commands into tokens, and if it recognizes the command that was just issued, it executes a particular behavior. For example, if the first two words of the command are store location, it updates our dictionary of locations using the remainder of the command as the dictionary key and the robot's current x and y coordinates as the values for that key. If the command begins with the words go to or go to the remainder of the command is processed as a string and it checks the location dictionary for a matching key. If a matching key exists, our simple action move client is issued a move command with the x and y coordinates stored in our dictionary.
Go home.
A lot of the challenges we faced with this project involved the localization of the robot. So in a regularly changing environment like the lab where backpacks and chairs and tables are being moved around on a daily basis, it made it hard for the robot to localize and figure out where he was within the map. He also had a hard time localizing in long symmetrical environments like the hallways of ISAT. Without any sort of variation in the surrounding environment, he couldn't really figure out where he was, so we had an issue with that for a little bit.
So So something we'd like to implement in the future would be to re-implement the follower node so that when we tell it to follow, it would follow you, and then when you tell it to stop, it would stop. Also, once again, what we started out with was a mechanical arm, but we couldn't get to that. We'd like to implement that because it would be useful to have the robot, be able to bring stuff to you, or take, like say, give it a bottle and go throw it into the trash can.
Lastly, something that we haven't even considered the actual possibility would be to take external maps and actually have the robot process that and have saved locations from that.
I did not understand that. Please repeat your last command.